Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon from all and everyone. Today we will discuss our next chapter about economic growth 2. In the previous session, we already talked about economic growth 2, presented by Mr. Choi, about capital accumulation and population growth. And in the second chapter of economic growth 2, we will talk about technology, empirics, and policy. But before we start the presentation, I want to remind you about the importance for us to know about this growth theory, especially about the economy in the very long run. As we all know that based on the real situation, for example, in India has grown rapidly in economic growth. Meanwhile, in another country such as Africa, they still live in poverty. So it is the job of growth theory to explain such disparity in income, and because it is have a big consequences for human welfare. So it is important for us to know about this economic growth. The learning objective today is technological progress. We will use the solo model like the previous session, and then we will talk about the policies to promote growth and growth empirics. It is confronting the theory with facts, and about endogenous growth. Two simple models in which the rate of technological progress is endogenous. In the previous session about solo model, we used the production technology is held constant. But in this chapter, because we know that technology is always improving, always have a progress, so in this chapter, the technological progress is fluctuated, and income per capita is constant in the steady state. I think we know that neither point is true in the real world. For example, for point 2, income per capita is constant. In 1929 to 2001, U.S. real GDP per person grew. I think it is happened in almost every country in this world that the GDP is always fluctuated. And then the example of technological progress to prove that technology is always developed. In 1970, 50,000 computers in the world, and in 2000, 55% of U.S. households have one or more computers. It is proof that almost everyone nowadays has the ability to purchase computer. The real price of computer power has fallen, so the computer is not a luxurious thing anymore. It is a common thing. And the average car built in 1996 contained more computer processing power than the first lunar landing craft. Modems are faster today, and semiconductor usage, and there are many more examples that prove that technological progress is always improving. Because technological progress is not constant in this chapter, so we have to add a new variable, which is E, or labor efficiency. Assume technological progress is labor augmenting, it increases labor efficiency at exogenous rate G. G is the rate of labor augmenting technological progress, so we will use G to measure the change in labor efficiency. We know, right, the production function as Y equal function of capital and labor times E. L is the number of actual workers, and E is the efficiency of each worker, where L times E equal the number of effective workers. Hence, increases in labor efficiency have the same effect on output as increases in the labor force. So L times E is the measure both workers and the technology with which the workers comes equipped. So the E is to define the technological progress. We have these two notation for output per effective worker and capital per effective worker. Production function per effective worker is Y equal function of lowercase k, and saving and investment per effective worker, saving times Y equals saving function of capital. Delta plus N plus G in bracket K equal break-even investment. Break-even investment is the amount of investment necessary to keep K constant. Delta K is to replace depreciating capital, and K to provide capital for new workers, GK to provide capital for the new effective workers created by technological progress. This is the curve in steady state model using Solow model. This is investment as function K is investment, and then delta plus N plus G in bracket K is the break-even investment. As you can see that these two curves intersects in a point of K stars that shows that the steady state of capital per worker. K star is the position of capital per worker in steady state. Steady state growth rates in the Solow model with technological progress. In steady state model, capital per effective worker is constant, so the steady state growth rate for capital per effective worker is 0. And because the output per effective worker, or Y, is function of lowercase k, so the growth rate of output per effective worker is also constant. And then output per worker is G, and total output, steady state growth rate for total output is N plus G. In the steady state condition, the rate of growth of output per worker and capital per worker, but there's not here in the table. It depends only on P, or efficiency of labor, or we can say that it depends on the technological progress, because the other factors is constant. So we can say that in steady state model using Solow using Solow model, the total output only depend on technological progress. To find the golden rule capital stock, express C star in terms of K star. C is consumption equal Y star minus I star. So we have this equation using the previous equation. C star is maximized when marginal per capital equal delta plus N plus G. Or equivalently, MPK minus delta equal N plus G. This is the condition on golden rule steady state, where the marginal production of capital minus depreciation equals the population growth, it's symbolized with N, and the rate of technological progress symbolized with G. We have to remember this equation because in next slide we will policies to promote growth. In every nation, there will always a policy to promote economic growth, but most of the economists are skeptical about this policy, and we have 4 policy questions that usually being questioned. The first one is, are we saving enough? Is it too much? What policies might change the saving rate? How should we allocate our investment between privately owned physical capital, public infrastructure, and human capital? And the last question is, what policies might encourage faster technological progress? We will answer this question one by one. And for the first question, are we saving enough or too much? We have to evaluating the rate of saving. We have to measure our rate of saving by using the golden rule to determine whether our saving rate in capital stock are too high, too low, or about right. Just like I said before, the steady state condition is when the marginal product net depreciation is equal to N plus G. So to do this, we need to compare MPK minus delta to N plus G. This is the condition if MPK minus depreciation is higher than N plus G, then we are below the golden rule steady state, and we should increase saving to get a higher consumption. And vice versa, then we are above the golden rule steady state and should reduce S to achieve a higher consumption. To estimate MPK net depreciation, we use 3 facts about the US economy. It is the example of the application in evaluating the rate of saving in US. For example, the capital is 2.5Y. It means that the capital stock is about 2.5 times 1 year's GDP. Delta K equal 0.1Y. About 10% of GDP is used to replace depreciating capital. And MPK times K equal 0.3Y. It means capital income is about 50% of GDP. Using these 3 facts, we will estimate the MPK minus depreciation. This is the equation for those 3 facts. And to determine depreciation, we have to divide the second equation by the first equation, like this. Delta K per K equal 0.1Y per 2.5Y. So the result is the depreciation is 40%. 40% per year. 4%. 4% per year. And to determine MPK, we have to divide the third equation by the first equation. MPK times K per K equals 0.3Y per 2.5Y. And the result for marginal product of capital is 12% per year. By those calculation, we can count the MPK minus depreciation. 0.12 minus 0.04 equals 0.08. So the marginal product of capital net depreciation is 8% per year. We know that the marginal product of capital net depreciation is 0.08. This is the new fact. US real GDP grows an average of 3% per year. So the growth of total output N plus 0.03. So in the US, NPK mean delta equal 0.8 is higher than 0.03 equal N plus G. So the conclusion is the US is below the golden rule steady state because NPK net depreciation is higher than total growth of total output. So if we increase our saving rate, we will have faster growth until we get to a new steady state with higher consumption per capita. So in this condition, the saving rate must be increased, so the higher consumption will be achieved. The second question about the policies to promote growth is what policies might change the saving rate? Policies to increase the saving rate, for example, reduce the government budget deficit or increase the budget surplus. I think this is the most direct way for government to increase the saving rate because it is easier for government to manage the public expenditure and can increase the public saving. Public saving is the difference between what government receives in tax revenue and what it spends. So it can counter is we have a budget deficit or budget surplus. When we have budget deficit, it will be a burden for our future generation because it will create a future debt and then raises interest rate and makes the investor to choose another country to invest. While we have budget surplus, we can fix the infrastructure in our country and we can stimulate the investment. So it is the easier way to government. Meanwhile, in increased incentive for private saving, the private saving is the saving done by household and firms. In general, how much people save depends on the incentives they get. It can be implemented by reduced capital gains tax, corporate income tax, estate tax as they discourage saving, replace federal income tax with a consumption tax, and expand tax incentive for IRS, individual retirement accounts, and other retirement saving accounts. And yes, most of it is heavily related with tax. And the third question we have to answer is how should we allocate our investment? In the solo model, there's one type of capital, but in the reality, there are many types. But in this lesson, we divide it into 3 categories. The first one is private capital stock. Private capital stock, such as machines, robots, and etc. And then public infrastructure, such as roads, bridges. And the last one is human capital, the knowledge and skills that work is acquired through education. This human capital is counted as capital because, like physical capital, it also increase our ability to produce goods and services. And in raising the level of human capital, we need to do an investment. For example, like we are doing today to get a higher degree, we invest in ourselves, in human capital to raise our level. And human capital and physical capital is considered as important, is equally important. And how should we allocate investment among these 3 types of capital? There are 2 points of economic investment to allocating the economy's investment. The first one is equalized tax treatment of all types of capital in all industries. Then let the market allocate investment to the type with the highest marginal product. It means that government have to ensure that the tax system treats all the forms of capital equally, and then rely on the market to allocate capital efficiently. So the government depends on the market. Meanwhile, the second industrial policy, it says that government should actively encourage investment in capital of certain types or in certain industries because they may have positive externalities that private investors don't consider. Positive externalities, it means that social returns to capital exceed the private returns and give greater benefits in increasing capital accumulation to society. For example, installing robot industry is have more positive externalities than building a mill, for example. So the government must prioritize the robot industries and give the tax law to encourage investment in robots. But there are also possible problems with this policy. The first problem is the government may not have the ability to pick winners because in industrial policy implementation, it requires the government to accurately measure the externalities of different economic activities, and it is considered virtually impossible, and it is risky if the government choose the poor measurement, so the effect will be random and maybe it will have no effect, just like there's no policy. And the second problem is concern that politics rather than economics would influence which industries get preferential treatment. I think it is happen in the public capital, that we all know that in making some public infrastructure, for example, the congressman or the local government must interference in this problem. So in the future, I think they will have a sense of managing this public infrastructure. So the politics is always influence the public infrastructure. And the first question is, what policies might encourage faster technological progress? Patent laws encourage innovation by granting temporary monopolies to investors of new products. And then tax incentive for research and development, grants to fund basic research at universities, and industrial policy like we saw before, encourage specific industries that are key for rapid technological progress. I think the most important thing in encouraging technological progress is patent laws. So if intellectual property rights is better enforced around the world, so firms would have more incentive to engage in research, and this will promote worldwide technological progress. So I think the most important one is intellectual rights. The next one is case study, will be presented by Sielvia.
So we will learn about this case study. Look at the table. There are the productivity slowdown in several countries. So in the early of 1970s, world policymakers faced a global slowdown in economic growth. This table This table presents data on the growth in the real GDP per person for 7 major world economies. For example, growth in US fell from 2.2% to 1.5%, and other countries experienced similar. Accumulated over many years, even a small change in the rate of growth has a large impact on economic well-being. So, although the decline in the US only from 2.2 to 1.5, the real income in US was about 20% lower. So, it is about the productivity slowdown in 7 major countries in the world. Okay, so the next question is why the condition appear or occur. So we continue to the next slide. The possible explanation. There are 4 hypotheses to explain the fall in economic growth. The first one is about measurement problems. The productivity slowdown did not really occur, it just shows up on the data. Because it is more difficult to measure about the increase or about the decrease in quality than to measure about the quantity. I mean, it is easier for us to measure the change in quantity if the company produce many more computers that are, increase the productivity quantity, it is easier to measure. But if they produce a better quality of computer or higher specification of computer, it is harder, it is more difficult to measure. So the slowdown of the productivity or of the GDP is about the measurement problem, because the quality or the GDP exactly is not easy to measure. And the second one is oil prices. There are oil shocks occurred about when productivity slowdown began. But the next question, why didn't productivity speed up when oil prices fell in the middle of 1980s? So the accumulated shortfall in productivity seems too large to be explained by increase of oil price. Oil is not that large fraction of the typical firm's cost. So oil is only a little part of the firm's cost. And then the third is about worker quality. In 1970s, there are several new entrants into labor force. For example, baby boomers. They are leaving school and then they come into the labor force seeking a job. And maybe full-timer women, they leave their house, or maybe they spend part of their time not only to manage their house, their family, but also they become a laborer. So maybe the baby boomers and women is the example of the new workers that are less productive than the experienced worker. And the fourth is the depletion of the ideas. Perhaps the slow growth in 1972 to 1995 is normal, and the anomaly is the rapid growth from 1948 to 1972. So, why there is anomaly before 1970s? Because 2 preceding decades, the idea of the economies was finally implemented after being suspended due to the Great Depression in the 1930s and the World War in the early 1940s. So the idea from the economies being suspended and finally can be implemented in this period, in this 1972 until 1995. So from 4 possible explanations, which one of these suspects is the culprit? So in this book, it described that the slowdown remains a mystery because all of them are plausible, but it is difficult to prove that any one of them is guilty. Okay, the next case study is about IT and the new economy. Okay, this is the data about growth in output per person. The continuation from the before. At the 1995 till 2000, the growth in US increased after it is declined from 2.2 to 1.5. It increased become 2.9 in the period of 1995 to 2000. So some economists proclaimed that they were living in a new economy because the percentage become higher than the decades before, than the 1948, only 2.2, and now and 2000 it became 2.9. But it is like the condition that sometimes patient's illness goes away on its own, even the doctor has failed to come up with a convincing diagnosis and remedy. So this condition or this case in the slowdown of the growth of economy have not yet figured it out, but beginning in the middle of 1990s, it is disappeared automatically, maybe, or undescribable. So apparently the computer revolution didn't affect aggregate productivity until the middle 1990s. It started to affect the productivity since 1990s. There are two reasons why there is a delay effect of the computer to the productivity. The first, because computer industry's share on GDP much bigger in the late of 1990s than earlier period. From the data, I get that the GDP is increased from 0.9% become 4.2%. It is a big increase, I think. So the second reason, maybe it takes time for firms to determine how to utilize new technology most effectively. For example, in the technology or invention of electricity light bulb, it needs decades until the electricity light bulb, it needs period, it needs time to bring it to the market, I mean. So the new technology influence growth with a long period, or maybe more than decade. So there are two big questions. Will the growth spurt of the late 1990s continue, and will IT remain an engine of growth? So let's go to the third objective of this chapter. It is about growth empirics, confronting the solo model with the facts. Solo model steady state exhibit balanced growth, many variables growth at the same rate. So many variables rise together in steady state. It's good in describing the long run data. So as it is described by the previous speaker, Liza, solo model predicts that Y per L and K per L grow at the same rate G, so that K per Y should be constant. This is true in the real world. On the data on the table before, for example, it is the data of US, that is 2%. And then solo model predicts real wage growth at same rate as Y per L, while real rental price is constant. This is also true in the real world, for example US, still 2%. So the solo model prediction about factor prices and the success of this prediction, the success of the solo model, very contrast with Karl Marx theory of the development of capitalist economies. Karl Marx said that return to capital will decline over time and lead economic and political crisis. So the next discussion is about convergence. I think this topic was asked by the captain of the class, Mas Hendrawan, in the past meeting. It is about India and US, if I'm not mistaken. So, about convergence, Solo model predicts that other things equal, that poor countries with lower Y per L and K per L should grow faster than rich ones. So, is it possible that poor countries become better than the developed country? We will see. If true, then the income gap between rich and poor countries would shrink over time and living standards converge. But in real world, many poor countries do not grow faster than rich ones. Does this mean that Solo model fail? The answer is no, because there is assumption, and in the real world, other things are equal. So, in samples of countries with similar savings and population growth rates, income gaps shrink about 2% per year. In larger samples, if one controls for differences in saving, population growth, and human capital, incomes converge by about 2% per year. So what the Solo model really predicts is conditional convergence, that countries converge to their own steady states, which are determined by saving, population growth, and education. And this prediction comes true in the real world. I think it is similar with us in our condition in this class, because we are 8 people here, and we have to study about the postgraduate of economy, but we have a different background. I mean, maybe some of you have educational background in economy or accounting, or like me about statistics. So our steady state is not the same. So if we learn together about this economy in this Brawijaya University, maybe if we want to reach the same point, I mean, our goal is same, is to graduate from this university with a great with successfully graduate. So maybe like this presentation for me, because my educational background is not from economy, so I need to read more, maybe twice, third, or maybe more than a week. But maybe for Mas Hendrawan, because he graduated from STAN and he know more about economy, so maybe just by skimming and scanning, so he can describe it well. So that's just an example, because the conclusion is about the convergence in growth. If countries or people or the area or something in the condition of the steady state is the same, so they have possibility to converge. But if they have different steady state, different educational background, different maybe in about countries, different population growth, different education in the basic point, they maybe should not expect convergence. If they expect convergence, they have to impose some policy or maybe some action. Maybe, for example, for me, I have to accelerate my study, I have to read more and anything. Okay, so there are two sources of income disparities about factor accumulation and production efficiency. Two reasons why income per capita are lower in some countries than others. First one is about differences in capital, whether it is about physical or human per worker. And the second is differences in the efficiency of production, which is the head of the production function. That is, a worker in a poor country may be poor because he lacks of tool and skill, or maybe vice versa, because the tool and skill she has now are not being put in their best use. So those two reasons are important, capital or efficiency in production, and countries with higher capital per worker